Welcome. In this explainer, we're going to look at two really important ideas from your GCSE Computer Science course, data security and compatibility. We'll be focusing specifically on encryption and standards. Have you ever stopped to think about all the information you send and receive online every day? How does it actually stay safe from unauthorized access? And how do all these different devices, made by so many different companies, manage to understand one another? Well, today, we're going to explore the two key concepts that make it all possible: encryption and standards. Okay, so to understand the risks involved, let's start with a quick recap of how data moves between computers. This should be familiar to you from a previous topic. You'll remember the client-server model, right? A client, like your web browser, requests something, say loading a web page. A server then provides that service. Now, for this to happen, data has to be sent across a network, and it often passes through lots of other systems on its way. And here's the crucial point. This journey introduces a security risk because the data could be intercepted along the way. And it's not just about websites. The exact same risk is there when you use cloud services. When you open a file from your cloud storage, that data isn't on your computer. It's on a remote server, and it has to travel across the internet to get to you. That means your data is constantly on the move and needs to be protected during its journey. So the single core risk that we're talking about here is this. Any data that's sent over a network, whether that's to a web server or a cloud provider, is vulnerable. It can be intercepted by someone who isn't authorized to see it. Right. So if we have to assume our data could be intercepted, how do we make sure it's completely useless to whoever grabs it? This brings us to our first major solution: encryption. So what is encryption? Put simply, it's the process of scrambling data into a format that's unreadable. The whole point is to protect the confidentiality of that data, making sure that even if someone does intercept it, they can't understand it. Now, this scrambling process isn't just random. It's controlled by something called a key, which is basically a value used by the encryption algorithm. To unscramble the data or decrypt it, you absolutely have to use the correct key. As you can see, with the correct key, the data becomes readable again. But if you try to use an incorrect key, all you get back is meaningless jumble. This is an incredibly important point to get right, especially in an exam. Encryption doesn't stop someone from capturing your data. An attacker can still intercept that packet of encrypted information. What encryption does is stop them from understanding it. Without the correct key, the data they've captured is completely worthless. And that's why encryption is absolutely essential for protecting all kinds of sensitive information online. We're talking about things like your passwords, your personal details, and your bank details. Systems like online banking, secure websites that start with HTTPS, and cloud storage, they all rely heavily on encryption to keep our critical data safe while it's in transit. Okay, so we've looked at how to keep our data secure, but that only solves half the problem. For the internet to actually work, we need to answer another question. How do all the different devices, made by thousands of different manufacturers, manage to communicate with each other? The solution is something called standards. A standard is simply an agreed-upon set of rules that all hardware and software manufacturers decide to follow. You can think of it like a common language that ensures all these different systems know how to talk to each other properly. Just try to imagine a world without them. A laptop from one company might not be able to connect to a wireless router made by another. The effect of not having standards is incompatibility, which would lead to constant communication failures. With standards in place, we get devices that can work together seamlessly. You actually use these standards every single day, probably without even thinking about it. Wi-Fi standards, for example, are what allow any Wi-Fi device to connect to any Wi-Fi router. The same goes for Ethernet and wired connections. In fact, all the network protocols you learn about, like TCP/IP, HTTP, and FTP, are all based on these agreed standards. So the key idea to take away here is that standards provide the consistency, the reliability, and the compatibility that a massive global system like the internet needs to function at all. They are the absolute bedrock of interoperability. Right. Let's pull these two big ideas, encryption and standards, together and focus on the key points you'll need to remember for your assessment. For your exam, you should be feeling confident answering questions like these. You'll need to be able to explain how encryption uses a key to protect data, why it's so necessary when sending data over a network, and also why standards are absolutely essential for networking. And finally, here is a fantastic tip for structuring your answers to get the highest marks. Don't just state a fact. First, explain what happens. For example, data is scrambled using a key. Then explain why it matters. This protects its confidentiality during transmission. And finally, state the effect. This means that any intercepted data is meaningless to an unauthorized party. If you can apply this what, why, effect structure, you'll be building really clear and comprehensive answers.